Yeah, thank you so much, Alice. I've had the privilege of studying high-performing technology organizations since 1999. That was a journey that started back when I was the CTO and founder of a company called Tripwire here in town, in the information security and compliance space. And so, as part of that study, our goal was to understand and study these high performers. These were the organizations that had the best project due date performance and development, that had best operational stability and reliability in ops. And they also had the best posture security and compliance. So the goal was to understand how did they make their good to great transformation so that we could understand how other organizations could replicate those amazing outcomes. And so in that, you can imagine in that 20-year journey, there were many surprises. But by far the biggest surprise was how it took me into the DevOps movement, which actually started when I was invited to the DevOpsDays in 2011 on the LinkedIn campus. And so I cannot tell you just how much I've learned since then. So the Phoenix project came out in 2013, and I was mentioning, I can't overstate just how much I've learned, many of them at DevOps Days, so my personal thanks to the programming committee for bringing DevOps Days here to my hometown, Portland, so thank you to them. Oh, actually, one thing that you may not know is there's a gentleman named Joe Nussbaum who's a part of the programming committee. I've actually known Joe for a very long time, because he and I were actually roommates in 1993 when we were both at Purdue University. So, hey Joe, wherever you are. Joe, where are you? Hey, Joe. All right. So much of what I learned, I try to put into these books. But something that I've wanted to do for a very long time. It will be coming out on November 26th this year, and it's called the Unicorn Project. Essentially, that is the Phoenix project retold, but from the perspective of a developer, specifically Maxine. Maxine is actually the person who actually caused the payroll outage that happened in the first 10 pages of the Phoenix project. So after nearly 3 years of work, spanning 1,600 hours of typing, this is coming out in a couple of months. I want to share with you some of the key principles behind it. And specifically, the reason I wanted to do this was because I wanted to capture the heroic journeys of the DevOps enterprise community, who are taking these DevOps principles and practices and trying to bring this into large, complex organizations, often having to fight a very powerful ancient order, that has been growing more and more powerful over the last 20 and 30 years. So in my mind, the mental model for this book is really red shirts from Star Trek, the A-Team, Hogan's Heroes, and the movie Brazil, where the number one fugitive in Brazil is a rogue air conditioner repairman who breaks into people's apartments, fixes their air conditioning because central services won't do it. And I can't imagine a better way to characterize what these amazing people in the DevOps enterprise community are doing. So in the Phoenix project, we had the 3 ways, the 4 types of work, and in the Unicorn project, we're using the 5 ideals. So in this presentation, what I'm going to do is just walk through the 5 ideals and show you, what it epitomizes and what the antithetical examples are. So the first is locality and simplicity. The second is focus, flow, and joy. The third is improvement of daily work. The fourth is psychological safety, and number 5 is customer focus. So the first one is locality and simplicity. So I think the best way the story that really made me have this aha moment was a story that I heard about the birth and death of a technology called Sprouter at Etsy. And essentially, this is a story about how engineers work together to create value for customers. And so in the bad old days of Etsy in 2008, so this is pre-Allspa days, in order to generate a feature, 2 teams would have to work together to create value. One was the developers on the front end in PHP, and the second were the DBAs who would make changes inside of the stored procedures inside of Postgres on the back end. And so that meant in order to generate a feature, these teams would have to communicate, coordinate, prioritize, schedule, maybe sequence, deconflict. And so even in the bad old days of Etsy, they knew this was a problem. And so their goal was to try to enable these teams to work independently and then meet in the middle somewhere else. And so that's why they created something called Sprouter. Sprouter stands for Stored Procedure Router. And the idea was these teams would work independently and then make a small change in Sprouter. And as Ian Malpass said, a senior engineer there, he said this required a degree of coordination and communication that was rarely achieved, to the extent that almost every deployment became a mini outage. And so what's amazing is that this is really a great example of Conway's Law, is that when we went from 2 teams having to communicate and coordinate to create value to 3 teams, right, now the amount of the lead time required to get into production goes up, the outcome of quality goes down, right? And essentially, it takes that much longer for customers to create value. So as part of the great rebirth of engineering culture at Etsy, their goal was to kill Sprouter. And so the goal was to fully enable the developers on the front end to make all the changes necessary for that feature by using like object relational models and so forth, right? So that they didn't have to coordinate with anyone else on the back end. And what they found was that in every part of the property where they eliminated Sprouter, suddenly lead times for deployment went way down, quality of outcomes went way up, right? And because it meant that they didn't have to communicate or coordinate with anybody, right? And I think what this shows, so again, the Conway's Law would predict this, as we went from 3 teams that had to work together down to 1, right? All of these great outcomes were a side effect. And so for me, the big lesson was that it's not enough to move boxes around on an org chart. What it means is that we have to have a software architecture that's congruent to that enables small teams to be able to work independently so they can develop, test, and deploy value without having to communicate, coordinate with many, many other teams. So, that's only 3, 2, or 1 teams at Etsy, right? In many large complex organizations, it's not 3 teams. This might be 46 different teams, right? In other words, if you open up a ticket on the left to initiate a deployment, you might have to deal with middleware teams, firewall teams, test teams, environment teams. It doesn't take a lot to go wrong before, when crossing 40, 50 different handoffs, where you are looking at lead times measured in months or maybe even quarters. By the way, how am I doing here so far? Is this, does this resonate with anybody? Thumbs up? Okay, so it's no wonder that outcomes are not so great when you have scenarios like this. So the first ideal is really about to what extent can teams independently develop and test and deploy value to customers without having to communicate, coordinate, synchronize, sequence, deconflict with other teams. The not ideal is that to deploy value to customers, we have to communicate with tens or maybe scores of other teams like the previous example. So a specific measure of this, in the Phoenix project, many of you are familiar with the bus factor, right? Specifically defined as how many people need to be hit by a bus before the project or service comes to a screeching halt or is in grave jeopardy, right? In the Phoenix project, we had a bus factor of 1. Right, because Brent was a bottleneck. If Brent got hit by a bus, all work, whether planned or unplanned, and any outage was jeopardized. So in the Unicorn project, we started talking about this other thing, and I call it the sort of the lunch factor. In other words, in order to get something done, how many people do you need to take out to lunch in order to make it so? Right, and so Amazon has this notion of a 2-pizza team, right? You want a team that is, can be fed by at most 2 pizzas. But when we have kind of this lack of locality in organizations, in order to get anything done, you might have to feed everybody in the building, right? You might have to schedule lunch with 43 different people, some of whom have never heard of you before, and that alone can take weeks, right? So that's an example of a high lunch factor. Ideally, we want a lunch factor of 1, or maybe the unit is number of pizzas. So another example of the first ideal is that every team has the expertise and capability to deploy value to customers, but they also have the authority, right, to make decisions within the team. The opposite is that in order to actually make a decision, you have to go up 2 levels, over, and down 2, right? And sometimes this is known as the square, right? In other words, every decision requires a square, and a friend of mine said, that's actually in the good case. In the bad case, you not only have to go up and over 2, but you actually have to do the return path, right, to actually get 2 engineers to work together, right? So this is an example of not ideal. Ideal is when when you want to implement a business feature, right, you can actually just look at 1 module, 1 file, 1 something, right, and make the change there, right? Not ideal is that in order to make a change, you have to understand all the files, or all the modules, or all the classes, right, all the containers. And so what it means is that we want to place a locality in our code. And incidentally, like a great example of this is that when you have cross-cutting concerns, right, that you can actually change it in one place. A great example of this is something I found initially incomprehensible, which is Kubernetes sidecars. Right? I didn't understand why they were there, but it means that you can have one team responsible for things like logging and monitoring, and it can just be put into one place, and now every container can leverage it. So I think that's just a great example of the first ideal. Okay, don't have time for that story. So that's the first ideal. Second one is the second ideal is focus, flow, and joy. So maybe just to give some context for this one, I want to make maybe a confession. So for almost 20 years, I've self-identified first as a security person, but for the majority of that, as an operations person. And this is despite getting my master's degree in compiler design and high-speed networking at the University of Arizona. And I think what always made me gravitate towards operations is that that's where the excitement was, right? That's where the saves were made, especially when you had developers who didn't know what they were doing. So for 20 years, I've self-identified as an ops person, but 3 years ago that changed, and really now I self-identify primarily now as a developer. And I think it changed when I learned a programming language called Clojure. It's a functional programming language. It's a Lisp. It was the hardest thing I've ever learned, but that more than anything else has really introduced joy of coding back into my daily life. And it's just amazing because there's certain things about it that allow development to be so productive, fun, and safe. And one of those core concepts is about immutability. So the famous French philosopher Claude Lévi-Strauss, he would say of certain tools, is this a good tool to think with? And I think immutability is one of the things that is definitely a better tool to think with. So at the core of functional programming languages like Haskell, OCaml, Clojure, Erlang, Elm, Elixir, right, Reason ML that was just released by Facebook, is this notion of immutability, that once you're not allowed to change things. And what's amazing to me is that even though that concept originated in programming languages for developers, we're seeing that show up in so many places in infrastructure and operations. So before I go there, right? So when I say that I self-identify as a developer, I mean I self-identify as a very fussy developer because there are certain things that I hate now, like everything outside of my application. I don't want to connect to anything like databases because it always takes me a week. Secrets management, I'm the guy who's always checking secrets into the repository. Bash, YAML, patching, Kubernetes YAML files, right? Incomprehensible to me. So this is not to say that operations isn't important. It's just that I hate doing these things. I would rather have a friend do it for me. So here's immutability again. Okay, so like immutability is showing up in operations too, right? So when you look at Docker, right? Docker is fundamentally immutable, right? You can't change the containers; they don't persist. Kubernetes, right? Uses that not just for the container, but for the entire infrastructure. Event streams, so often Kafka is being used, to create an immutable compute model. So when I say that I detest infrastructure, it means that more and more, I think developers are relying on infrastructure teams and platform teams to help do what they need to do. So the second ideal is all about an ideal being that your energy and time is being focused on solving the business problems, right? And you're actually having fun doing them because you're doing the work that you love. The second is that you're spending all your time solving problems that you don't really want to even solve in the first place, right? Like, how do I deal with spaces and file names inside of makefiles? And I guess you can't, right? So I learned that after a day. Someone told me you can actually use a $$ in makefiles. And I actually got angry because I actually knew that 20 years ago, but I don't want to know that anymore. So let me justify that. And I think the reason why I get so angry when I have to Google things like that is that there are really two types of learning. There's procedural learning, and there's something called one-shot learning. So procedural learning, or maybe declarative learning, is the type of learning that you value, right? For example, there are certain things that you've learned over decades, and everything that you learn and build on top of that, you value because it will serve you for decades to come, right? On the other hand, one-shot learning is like when you Google, how do I deal with double spaces, spaces in makefiles, right? I don't really care, right? But I have to solve it. In fact, I resent having to solve that problem. So, in fact, I can give you a very concrete example of this. I wrote this application to deal with Trello card management, and I was so happy that inside of Clojure and Clojure script, I can write all these great features, and then you can see this big dip, like in 1 week. And that was when I was trying to move it from my laptop into Heroku, and that's when I had to deal with YAML files and environment variables and secrets. I spent a week doing that. In fact, I was traveling. I was up till 2 a.m. just trying to get it working. And you can actually see kind of the dip in the productivity of the things I wanted to do, right? And so all of this leads to, in fact, I even have screenshots of all my Google searches, for weeks of things that, if I want to get angry, I just look at that. And so this is really my long way of saying that I think the best days of ops and infrastructure are still to come. right? Is that to get developers productive, we really do need the platforms to embody all the expertise of infrastructure and operations. In fact, I think very concretely, the things that we love about platforms, right, and I think what makes me so excited about all these platforms emerging is that we can do so many things to make developers productive by giving them things that they need, self-service, on-demand, with immediacy, which allows the conditions for fast feedback, which, if you look at the books like Flow by Mihaly, I'm going to learn how to pronounce his word. It's a great TED Talk. These immediacy and fast feedback are the conditions that enable focus and flow and even joy, right? And there's so many things. There's almost everything you can get now, with these type of characteristics. By the way, I just want to share one joke that came from Jeffrey Snover, technical fellow at Microsoft. Bash is a disease you die with, but you don't die of, right? All right. And by the way, we can't leave the second. Okay, yes, we can. All right, third, enablement. The third is about improvement of daily work, right? In other words, this actually was in the Phoenix project, where this requires that we prioritize improvement of daily work even over daily work itself. And so I think one of the best examples of the opposite of the third ideal is the General Motors plant in Fremont, which is where was the site of the famous Newbie joint venture with General Motors and is now the primary Tesla manufacturing plant. And so there are many recorded cases where not only there were no effective procedures in place to detect problems during the assembly process, there were no explicit procedures on what to do when problems were found. And so there are many instances of engines being put in backwards, cars missing steering wheels or tires, cars even having to be towed off the assembly line because they wouldn't start. Right, and so we all know that's bad, right? And so isn't it interesting that the ideal really is that we want to create a system where we have feedback in our system from as many areas of the system as possible, sooner, faster, and cheaper, with as much clarity between cause and effect. And the reason that's so important is that the more assumptions we can invalidate, the more that we can learn. The more that we learn, that enables us to outlearn the competition. And so, of course, the best embodiment of this, the paragon of this principle, is without doubt the Toyota Andon cord. And so I spent a week at the University of Michigan back in 2011 getting trained in the Toyota production process. And it really was amazing to find out that on top of work centers modeled after the Toyota production system is this cord that everyone's trained to pull, right? And you pull it whenever something goes wrong, like you create a defective part, or you get a defective part from someone else, or there are no parts to work on. Or even if the work that you're doing takes longer than documented. If it was supposed to take 55 seconds and it took 1:20, right, you pull the cord. And everybody knows what happens when you pull the cord, right? The assembly line stops. So I knew that going into the training. What I didn't know was that how many times in a typical day the Andon cord was pulled. And so just in your head, think how many times is the Andon cord pulled every day in a typical Toyota plant? And the answer is 3,500 times a day, right? And so it just shows, and each time it happens, right, everyone says thank you, right? Thank you for helping us see and therefore solve a problem. So how does this apply to our work? And I think it applies a lot more than we think, and it has a very tight relationship with technical debt. So let me tell you about a story about technical debt. So I'm going to tell you a story using only up and down arrows. Someone wise once told me, when dealing with executives, stick only with small numbers and primary colors, which I think is very funny, but is actually not sufficient. When you're dealing with sufficiently senior people, you must be able to tell stories using only up and down, right? Because that's causality. So imagine when you've been in a position where you've had to push to market, right? In order to be first to market, even second to market, right? And so you're doing everything you can to get features into production. And when you're pushing, you have to cut corners, and so that's where debt and risks come from. And so as a result, quality goes down, and then defects go up, right? But it doesn't end there, right? Is that when you continue the story, what happens is that feature velocity goes down, and defects go up to the point where you're spending all your time just fixing defects. And so this is when site reliability tanks, you're getting slower and slower, customers leave, morale plunges, and devs are leaving because everything is so hard, right? In fact, a concrete example came from John Cutler, and he said in 2015, a certain reference feature would take 1 to 2 weeks, or let's call it 15 to 30 days, and then 3 years later, the same class of features takes 10 times longer. right? And so if you're imagining that this is happening to you, right, you're right. Right? These things do happen. And so I think one of the best examples of this happening at grand scale was Nokia. There's an amazing book called Transforming Nokia by Risto Salasma. He was the chairman of Nokia from 2008, and it still is. And he said in 2010, during a board meeting, when he learned that the Symbian OS build took 48 hours, he said it felt like being hit in the head with a sledgehammer, because it meant that it would take at minimum 48 hours for a developer to learn whether a change worked or whether they would have to redo it. And when he learned that, he knew that all the promises made by the R&D organization, everything of which near-term profitability and long-term viability hinged upon, was a mirage, right? And I think that is how lethal technical debt is. So it turns out it's not just Nokia that went through something like this, that almost every tech giant has gone through this, whether it's eBay in 1999, 2002 at Microsoft because of the summer of worms, Google 2005 that led to the automated testing culture, Amazon 2004, which led to the creation of the famous 12-point memo from Jeff Bezos, Twitter, LinkedIn, and Etsy, so forth. So I think one of the best examples, and what they have all done, is this notion of a feature freeze. I think one of the best examples was Microsoft, where he sent a letter to the entire company saying that if a developer or anybody has to choose between a feature or security, you always choose security, because that was the level of which the importance rise, right? It was existential risk. And so, what does a feature freeze look like? It means that we are taking features down to zero, so that we allow us to pay down technical debt, which allows us to increase our quality and drive defects down. Maybe not to zero, but certainly down, and that is what allows us to bring feature velocity back up. Right? And it's not just, what's interesting is that most of these companies that went through something like this, the CEO actually came from a technology software background. But it's not everyone. This advice is actually given by Marty Kagan in his famous book, Inspired, which is one of the books held in the highest esteem in the product management community, in the UX community. And so why would Marty Kagan say this? It's because he was VP of product management at eBay in the early 2000s. And during his 2 years at eBay, he never shipped one feature because all the engineers' time was spent just trying to keep the site up. Right? And so his advice is that if you don't pay your 20% tax, right, 20% of all cycles must be given to development and operations to use however they best see fit, right, to fix problem areas of code, problematic areas of operations. And if you don't do this, if you don't pay your 20% tax, you will inevitably pay 100% tax, right, where you will not be able to ship a feature. What's interesting, I think, in sort of this wonderful karmic continuation, Satya Nadella, the CEO of Microsoft, recently has started saying to all developers, if you have to choose between a feature or dev productivity, you must always choose dev productivity, right? And I think this just shows how important enabling developer productivity is, and platforms are a big piece of that. So in these tech giants in general, right, the ideal, they are spending 3 to 5% of all developer effort on improving developer productivity. It's certainly true at Google, at LinkedIn. And not ideal, the people who are working on builds and CI pipelines and so forth are the summer interns. These are the people who are not good enough to be real developers. So let's put them on infrastructure, right? So it has been said. All right, third ideal. No one cares if someone breaks the build or checks in code that breaks their tests, right? Ideal is, that is considered the most important work. Not ideal. When someone needs a peer review, that person has to wait until a senior person frees up. Often, I've even heard stories from a hero of mine, Elizabeth Hendrickson, where they needed not a +1, they needed a +2. And it meant that for 2 weeks, this junior engineer would have to redo their code, merge in all the things, make their feature work, just to wait. They were spending 2 hours just trying to keep their feature running, to be ready for their peer review for 2 weeks. Ideal, if I'm doing my daily work, doing whatever I think is the most important, I'll drop whatever I'm doing to help this person get into production, because we know that the longer this person waits, the worse the outcomes are going to be when they finally do go into production. Okay. Ideal number 4, psychological safety. So this was in the early days of the State of DevOps report, and it's among my favorites. And so there was one model that we use extensively called the Westrum Organizational Typology Model. And what Dr. Ron Westrum discovered in the healthcare industry back in 2004 was that organizational culture was one of the top predictors of performance. And what we found was that in organizations with the worst patient outcomes, they were typified by information being hidden, messengers of bad news being shot, responsibilities and bridging between teams was being discouraged, failure is covered up, and new ideas are crushed. In the middle, you have this notion of a just culture or bureaucratic culture. That's meant to be merciful. But in the highest performers, where you have the best patient outcomes, we found something. He found something very different. Information is actively sought all the time. Messengers are trained to tell bad news. In other words, a great example of this is when engineers are trained to lead blameless postmortems or blameless post-incident reviews. Right, that's such a great example of reinforcing that tone. Bridging between teams is rewarded, failure causes a genuine sense of inquiry, and new ideas are welcomed. Right, so one of the strongest, actually now we can say predictors of performance was organizational culture. What was so exciting is that even Google, that predated the State of DevOps report, they did a whole bunch of work around Project Aristotle and Oxygen, which eventually got rebranded as Project Rework. They were trying to understand what made great teams. Was it the manager? Was it was it the way that they organized the teams? But at the top of every list was psychological safety, and they defined it in a very specific way, which was to what extent do people on the team feel safe to share their opinions without being called out, castigated, and so forth. And they found over and over that psychological safety was one of the most important things that enabled teams to be great. And so it is psychological safety that allows things like blameless postmortems, chaos monkey, right? I mean, it has to be made safe to do those things. All right. So last of the 5 ideals, customer focus. And so this really came from studying the DevOps enterprise community. For the last, since 2014, I've been helping run a conference called the DevOps Enterprise Summit. And so in the beginning, this was a conference meant for horses by horses. Not the unicorns, Google, Amazon, Netflix, Facebook, Microsoft, large complex organizations who have been around for decades or even centuries, right, who are taking DevOps principles and practices and creating greatness in their organizations. And so over the last 7 years, we've had over 250 technology leaders share what they've done. And I think one of the best examples to me was Heather Mickman. She was then Director of Development at Target. And I got to follow her around for a day, actually 3 days. And when I saw on her desk this thing, it was like a certificate that was printed on an inkjet printer, which apparently these days, it's not PrintShop Pro, it's PowerPoint, right? That's how you generate certificates like that. It says Lifetime Achievement Award presented to Heather O'Sullivan Mickman for annihilating TEP and LARB. So what is TEP and LARB? So TEP stands for the Technology Evaluation Process. LARB stands for the Lead Architecture Review Board. Right? And so whenever, the reason why this is important is that whenever you want to do something new, you first have to fill out the TEP form and then pitch to the LARB meeting. So you walk into a room, there are 2 tables. On one table, you have all the dev architects. On the other table, you have all the ops and security architects. And then on another table, you have the enterprise architects. And then they pepper you with questions. You answer them. They assign you more questions. And they say, come back next month, and we will reevaluate your proposal. And her reaction was, no one on my team should ever have to go through this. In fact, none of the 3,000 engineers at Target should have to go through this. And due to her relentless lobbying, 8 months later, they disbanded the TEP and LARB, earning her this incredible certificate that hung proudly on her desk for many, many years. And so this is one of the things that we found, and again, in the State of DevOps report, was this notion of transformational leadership. The notion that does a leader understand the vision of the organization, the greatest problems that the organizations face? Do they have intellectual stimulation? To what extent can they challenge basic assumptions of how work is done? Can they challenge status quo? Third is inspirational communication. Can they overcome maybe fears about what this does to their functional silo? Or can they create a coalition of people to help overcome these very powerful, entrenched orthodoxies? Supportive leadership. personal recognition. And we found that these definitely helped predict organizational performance and IT performance. So one of the things this leads to is a question of not ideals, that functional silo managers, are they behaving like business leaders or more like union leaders? In other words, do they care about the survival of the silo, or do they care about the long-term aspirations and goals and needs of the organization? And I think one of the best examples of this I got to see in January of this year that had a tremendous impact on the book when I was at CompuWare with Dr. McKirsten. And they gave us a data center tour, which I thought was very peculiar because I've seen my share of Halon fire extinguishers. I don't think I need to see another one. But what I saw blew my mind because what I saw was this. It was empty. And so there's outlines, like in a murder scene, of every place where there was a server rack. And there's a little placard that says, here is the business system that this used to reside here and how much money was saved. And so you can see on the sign, there's over 10 tons or 16 tons of equipment that has been disposed of and recycled. And so I think what I found so inspiring was just imagine how that data center lead, the head of IT felt, right? Now that his top job was to dismantle the empire that he's been building, spent the last 10 years building up. So really the principle behind this notion of core versus context, right, is really understanding what creates core competency, what creates competitive advantage in the marketplace versus those that just support it. They may be mission critical, but they do not create competitive advantage. In other words, having a world-class payroll system, right, does not help us compete and win in the marketplace. So I think this is important for a variety of reasons because I think DevOps is important, not just for the unicorns, but for horses as well. I do want to share just a couple things about the Phoenix project and the Unicorn project. Here's a cast of characters for the Unicorn project. The ones that showed up in the Phoenix project are outlined in red. And you can see they're the bridge crew and Starfleet Command, whereas the Unicorn project is really about the red shirts, right? The developers doing the daily work and the engineers doing daily work to get things done. In fact, the only real overlap, is Brent, right? So, which I find very satisfying. So again, the publication date is actually November 26th, and in the next week or two, we will be starting to release the first excerpts of the book. So if you are interested in getting notified when the first Unicorn Project excerpts are available, or if you want all the excerpts from the other books, or if you want any of the videos and slides from all of the DevOps Enterprise presentations, all you have to do is pick up your phone and email realgenekim@sendyourslides.com, subject line DevOps. So don't take a picture, pick up your phone, and just send an email to realgenekim@sendyourslides.com, subject line DevOps, and you'll get an automated response in a couple of minutes. And I'll tweet that out as well. So thank you so much, and I'll see you during the rest of the day.